Okay, day 2. All right. We have trapezoid and rhombus. We went over these formulas on Friday. I do it this way. Friday, all those formulas, parallelogram and triangle, are on your reference sheet in the back. You'll know those next week for the test. These two, not given on the formula sheet. This is your responsibility. So trapezoid. I'm not going to have you go back and look. Let's just write it down. 1/2 the height times the sum of the two bases. And remember, the bases in a trapezoid are the two parallel sides. There's trapezoid, and then rhombus, which we're going to start today off with. 1/2 diagonal 1 times diagonal 2. D1, D2. Remember, and I'll go over the property right now, diagonals are never congruent in a rhombus. That's a rectangle. So those two values I should not be having the same. What I do need you to do in your group real quick is, hey, how many rhombus properties can you remember? Because I'm not going to feed you the diagonals and just say, go, what's the area? All right. Those diagonals are going to be tough to come by, and you're going to need your properties from the quad unit to get those diagonal lengths. So as many as you can come up with right now in the next minute, go ahead in your group. How many can you come up with?
Slow down there, buddy.
These are congruent to opposite.
All right. All right, let's go. Let's start listing off some of them here. 27, one property. All sides congruent. Yep. I know one. I know them all. All sides congruent. Another property. Get rid of that. Get out of here. Okay. Another property here. 7. There you go. It is also, remember, it's a parallelogram. So any parallelogram property it's going to have, including this one. This will be a huge one for us today. Diagonals bisect each other. And really looking for one more big one. You could tell me others, that's fine. But one more big one I'm looking for here. Let's go. It's 13. Not congruent, but they're perpendicular. There you go. And I'm just going to leave these 3. If you came up with others and listed them, that's fine. Leave them. But those are the big 3 here as far as finding the area. All right, so let's go to the first example here. I'm going to tell you one diagonal is 6. The whole area is 48 of this rhombus. How about the other diagonal? All right, what's the other diagonal length? So right away, oh, you're telling me it's a rhombus? Up pops the rhombus formula. D1 times D2. Take a half of it. Going over back to you guys. 20. Where should I put that 6 feet? D1. Yep. So 1/2 times 6. And how about that 48? What's that 48 telling me? 23? Area. So it's going to go in for A. 48 equals that times, what the heck's the other diagonal? I don't think you should have an issue substituting in those values, but I just want to make sure algebraically we're all right solving this. You got 48, right? Half of 6 is 3 with the x. And then, yes, you divide on both sides by 3. X equals 16. If you are going to put units, this would not be square units. We're not finding the area. We're just finding a length. So that would just be plain feet. Any issues? All right, now let's get a little bit more complex. How about the area of this rhombus? All right, no diagonals given. That's why now we got to resort back to the properties. One diagonal length you can find very quickly, though. Very quickly using one of the properties. 9. What's one diagonal length you're pretty sure of? 80. Diagonals bisect each other. So if one side's 40, this other part's 40 for a total diagonal of 80. Good work. All right, now we have to work for the other diagonal because they're not congruent. Stop with that. Not congruent. All right, going back to the properties, we were told that the diagonals are perpendicular, which forms a right triangle. And now what can I use to my advantage to find at least half of the other diagonal? 13, what's getting busted out here? Pythag. Perfect. Perfect. I'd love to know where you're plugging that 40 and 50 in, though. Where are you going to plug 40 and 50 into Pythag? 28.
40 squared plus a b squared.
Good, Tyler. That 50 is the hypotenuse, not a leg. So it should go in for c squared. We are moving today. How about that b value when you're ready? 26 when you're ready, that b value. What's the deal? We're just going to go with it? Just going to keep doing this? 16? What is it? 30. Thank you. Hopefully you didn't plug that 30 in, though. What am I plugging into the formula? Certainly not plugging 30 in. 15? 60. Double it. Be careful there. So we end up with, what do we got there? 240? Yeah. 24. What do we have here? Yeah, 2,400 square inches. Good. Everyone go with the old rhombus. Trapezoid. Whoa, before we work, what's already given to you? What are you going to plug into the formula already? What's there for you? 15 again.
Base 1, 6.
That's all I gave you?
And 11.
And 11, thank you. 2 bases are given. We're going to have to work for our height. Before we get the height, I want you to recognize where the heights are located. All right? Without drawing in anything, we could say AD is the height. Right? Vertice perpendicular to the opposite side. Or, and this is what I'm going to do, we could draw in the height coming from vertice B perpendicular to the opposite side. Either one's the same length. So it doesn't matter which one you find. I just think finding the one we just drew in is going to be a little easier because it's part of a 45, 45, 90. Which brings us to our next problem. I don't know any sides of that 45, 45, 90 to apply any of those rules you guys came up with in your groups on Friday. I don't know any of the sides. Can somebody help me get to a side length? 27, help me get to a side length. How's Pythag?
Oh, because when you drew the height,
Yep.
that point front to C is 5. Because
How do you know? How'd you get that? That's what I'm asking of you. How do you get to that point? Okay, I get, yes, that is going to be 5, but how?
you subtract the 2 bases.
That's 6. I just formed a rectangle, opposite sides congruent. That's 6. The whole thing was 11. Subtract it, the 6 from it, you get the 5. Yes. Is the 5 a leg or the hypotenuse in the 45, 45, 90? Leg or hypotenuse? 2? Leg, and what did we learn about the legs on Friday? In a 45, 45, 90, the legs are congruent. So if that leg's 5, the other leg, aka my height, is also 5. And then we get 42 and a half. We all good? All right, how about this trapezoid now? I gave you the bases again. Seven plus 11. Now the height, if you want to find SR, find it. I'm going to find the one drawn in from P. And all right, everyone good? One side of that 30, 60, 90 is going to be 4, a length of 4. Okay, in a 30, 60, 90, you got a shorter, a longer leg, and a hypotenuse. What's the 4 we just wrote down? Shorter, longer leg, or the hypotenuse? 28? Shorter. And what's the height, Tyler, while we're here? Longer or hypotenuse?
Longer.
Longer. All right, so on Friday we wrote down this rule. Longer leg equals shorter leg times 17? Radical 3, good. So if I take that 4 and multiply it by radical 3, I get 4 radical 3. Welcome to honors today, because if you notice the directions, doesn't say nearest 10th anymore. Oh, so sad. It says simplest radical form. And I do have a radical in my calculations. So that radical should be appearing in my answer. Simplest radical form. What do I do with the rest? You multiply them, right? That's what we're doing between 1/2 times 4 times, this ends up being 18, times radical 3. All right, so all I'm doing is 1/2 times 4 times 18 and put my radical 3 with it. That would be simplest radical form. And finish that off for me. Simplest radical form 4. There you go. Nice work, everyone. One of my favorites coming up here. Amelia designed the pennant. Can we just talk about the pennant real quick? If anybody's spotting some details here. The E team, Aaron, Amelia, and Alina. Nope, nobody in here would be joining the E team, correct? I had 2 people last class join the E team, but nobody in here can join the E team. If you don't know what I'm talking about, because your first name doesn't begin with E, that's the only way you're on the E team. All right. Oh, Ellie. Sorry, Ellie.
And Emma.
And geez, I'm awful at this. I'm awful. Yeah. Oh, I got two joining the E team. Nice. The team with the edge. E. Okay, never mind. Sorry, ladies. Our team's grown by 2 now. Good. What did I give you here already? I already spotted you a couple values. What values can you automatically plug into the formula? 27 again. Height, 4, right? Everyone sees the height is 4. Anything else, Andre? 10 for one of the bases. So it looks like we got to find the other base. And everyone see the other base right here? I'll highlight it in green. I got to figure out how long that base is. And that's going to be the job of you and your group. I'll see you back here in another minute or 2. How do I find that base length? A lot of discussion here.
So just add this question.
A little bit tougher than the other ones. I do want to give credit, because I'm not going to do it this way. I do want to give credit to people who added on this extra right triangle here and did it that way. Nice work. All right, nice work. That's one approach. The way I approached it here is I drew in the other height. Knew it was 4 already. And then I took this right triangle here and did a little Pythagorean theorem to find B. So I did 4 squared plus b squared equals 8.5 squared. And I got that value to be 7.5. The whole thing was the whole base was originally 10. Subtract it from 7.5, you get 2.5, which matches the base I was looking for. So 2.5 for a total area of 25 square inches. All right, 25 square inches. Okay, I am not going to say a word for number 5. You guys are on your own. Hopefully, you were paying attention during homework, because now it's not a 30-60 or a 45-45, or can't even use Pythag here. All I'm going to do is write the perimeter and the area up here, and you guys, once you have it, move on to the assignment for tonight. Okay, work on it with each other, alone. Don't struggle in silence. Call me over if you need it. Don't round in the middle. Do not round in the middle of your problem.
Bro, you know metabolism of nothing. Yeah.